Okay, so here we go, starting off the second semester. This is Unit 3, Lesson 1. And today we're going to be learning how to solve a one-step equation that involves addition and subtraction. Okay, and I want you to pay attention to the objective because this is a big deal here. The answer is important, but how you get that answer is even more important. So in the directions you're going to see, all right, where it says we want to be able to show the work necessary to solve an equation. Okay. First semester we did a lot of simplifying with expressions. Second semester is going to be a lot of solving with equations. All right, so we have 4 simple steps to help us accomplish this task. Step number 1 is we're going to look at the variable and ask a very simple question. What is being done to this variable? And the answer is going to be one of 4 things. We're either adding, subtracting, multiplying, or dividing. Okay? Then we're going to do the opposite. And remember, whatever we do to one side of an equation, we have to do the exact same thing to the other side. This is a big step here. And then we'll calculate our answer from there. All right? Now, notice there's a little reminder here, which again says when working with an equation, whatever you do to one side of the equation, all right, you must do the exact same to the other side. All right. So, example 1, the directions ask us to write our answer to step 1 and 2. So let's go back and review step 1 and 2. Step 1 asks the question, what is being done to the variable? So when I look at this, all right, step 1 is asking what's being done to the variable. I look at my variable, all right, and I notice that I am subtracting 6 from it. All right, so I'm just going to write a minus 6 here. And then step 2 is what's the opposite? Well, the opposite is plus 6. And that's all we're doing, making sure we could identify what is going on in the problem. Okay? Looking at B. Now, there's a couple of ways of handling this problem, but without doing any sign changing, what we're going to do is take a look at, again, what's being done to the variable. So when I look at this variable, in this case it's y, I could see that I am adding a negative 7. And the opposite of adding negative 7 is subtracting negative 7. Okay? And then in the third example, notice my z, my variable, is on the other side of the equal sign. That does not matter. The way we solve an equation, all right, is we always start with where the variable is in the problem. All right, so in this particular case, I'm adding 10, and the opposite of that would be to subtract 10. Okay, so again, understanding the opposites of the operations is a big deal in terms of solving. So let's go ahead now and actually solve some equations. Okay, looking at example 2. All right, again, first thing I'm going to do is just kind of notice where my variable is in each problem. Okay, you see it right there. That's the thing that has to be 100% by itself in order for this equation to be considered solved. All right, so I'm going to look at what's being done to the variable. I can see that I'm adding 4. The opposite of adding 4 is subtracting 4. Whatever I do to one side, I have to do the exact same thing to the other side, so I'm going to subtract 4 from there. Now, over here, positive 4 and negative 4, that's 0, so I don't need it anymore. And I'm going to drop my x down. On this side, 10 minus 4 is 6, and we have solved for x. X is now by itself. Okay? When we look at equations, this equal sign is like a brick wall. All right? It should pretty much just follow straight down the page. I'm a little bit off here, but you want to make sure that equal sign doesn't move on you. All right? People have a bad habit of putting equal sign over here, all right, or rewriting the problem off to the side. Keep everything in line as you solve equations. It's going to help you out a lot. All right, take a look at B. B is a tricky one, okay, because people see negative 10 plus y, and they often think, oh, we're adding 10 because of that plus sign right there. Well, if you think we're adding 10, that means the opposite is subtracting 10. And if I subtract 10 from one side, I have to subtract 10 from the other side. Here's the problem with that. Negative 10 minus 10 is not 0. It's negative 20. And if I want to solve, I need this thing to cancel out. So it's important to understand we need to read the sign that is in front of the number, not the sign that is behind the number when it comes to adding and subtracting. Okay, so we are technically here adding a negative 10, which means I'm going to subtract a negative 10, which is the same as adding. All right, so I'm going to double check my work again. All right, negative 10 and positive 10 is 0. That cancels out. That was my goal. Now I have my y equals, and then over here I have 14. All right, again, keep in mind this equal sign stays in a straight line, or as straight as you could get it. All right, you're going to go ahead and do C on your own. All right, and we'll check that answer tomorrow in class as I come around. It's something you got to have an answer for. Don't leave it blank. All right, let's take a look at example 3. All right, the first set of examples was all addition. You'll notice in this case we're doing a lot of subtraction now. Here's my x here, there's my variable, and there's my variable. All right, I look at what's being done to the variable. We're subtracting 4. The opposite of subtraction is addition. So I'm going to add 4. Whatever I do to one side, I do to the other side. Again, I'm going to read my work. I'm not going to assume that I did this right. Negative 4, positive 4, that's 0. That is why I'm able to cancel that out. On this side, simple addition gets me 14. All right. Moving on to B here. All right. Again, we look at what's being done to the variable. Notice my variable in this particular problem is on the right-hand side. That is where I begin. I don't even look at the 4. The 4 has nothing to do with the variable. The 10 is what's working with the variable, and you can see that we're subtracting 10. And the opposite of subtracting 10 is adding 10. Again, I'm going to add 10 to both sides. All right. When I look at this now, again, I'm going to read negative 10 plus 10. That is 0. I get to cancel that out. Over here, I have 14. All right. Again, you're going to do C on your own, and I'm going to check this in tomorrow. Okay, so make sure that is done. You need to have work there. All right, in our last example set, all right, and we're not done after this example. We're going to go back and check our answers. All right, but I want to make sure we go through all the solving first. Example 4, again, we're solving the equations, and we get to these problems that are double signed. And those things have always been a problem. All right, from day one when we started with order of operations, all right, we've had problems with double sign expressions and now with equations. So what I'm going to recommend that we do here is get rid of the double sign. And that's going to cause me to rewrite this. So I'm going to take the time to actually do this. A negative times a negative we know is a positive. So I'm going to change the problem to x plus 5. I'm going to come over to B. A positive times a negative is a negative. So I'm going to change this problem to x minus 5. And then same thing over here. Positive times a negative is a negative. So I'm going to change it to a subtraction problem. Now, again, notice nothing else changed. I still have to get this variable by itself. Now it's just looking at what's being done. We're adding, the opposite of adding, subtracting. Whatever I do to one side, I do to the other. All right, this is going to be 2. And I have my x by itself. Wrong color. Oh, well. Notice the equal sign, straight down still. All right, my equal sign, straight down the line. All right, I'm going to add 5 to both sides because that's the opposite of subtracting it. Negative 5 and positive 5 is 0. It cancels out. I'm left with y is equal to, and then on this side I add my numbers to get 12. All right, and once again we're going to leave the last one for you. All right, but before we finish this video, what we're going to do is go back up to the top in example 2 and talk about how we could check our answers. One of the great things about equations is you will know if you're right or wrong every single time. All you need to do is take your answer and plug it into the original problem for x. So in example 2a, we found x to be 6. If I take 6 and plug it in for x, that becomes 6 plus 4, and 6 plus 4 is 10. And notice we have 10 equals 10. So this thing checks because we know that's right. 10 does equal 10. All right. Looking at the next one, I'm going to take my 14 and put it in for y. So I have negative 10 plus 14. Negative 10 plus 14 is 4, and that's what I need it to equal. So I know this is right. Moving on. 14 goes in. 14 minus 4 is 10. 10 equals 10. That checks. Next one, again, 14 minus 10, that equals 4. 4 equals 4. That checks. I'm kind of speeding up a little bit here. Alright, last one, put the 2 in. Now, I would strongly encourage you to put the 2 into the original equation. Just in case you made a sign mistake, this is how you'll catch it. But you got to be really careful. 2 minus negative 5. Alright, again, leave, change. There's your 7. 7 equals 7. That checks out. 12 goes in here. 12 plus negative 5. We would have different signs, so I would subtract, keep the sign of the bigger number. Positive 7 equals positive 7. Alright, so that's solving one-step equations with inverse operations. Alright, specifically with dealing with problems where we have addition and subtraction. Alright, see you tomorrow.